Um, so to get us started, like you mentioned, I'm a software developer at InnoSquare. Usually work with JVM or mobile, usually Android. And TestContainers is a library that simplifies your integration tests. So it makes them easier to run and more reliable by using Docker. And to get us started, we'll have a quick poll. So raise your hands if this applies to you. Who here writes tests? Yeah, mostly everyone's hands. Who here writes unit tests? All right, pretty much everyone again. Who here writes integration tests? And the definition for this is usually works with like an external dependency. So less hands here. And of those people, how many people actually like writing integration tests? One person. What? Get out. No. No. So some of the reasons why we don't like integration testing, it's hard. Why is it hard? If you join a project, for example, you need to install things just to get your tests to run. So it might be a specific version of a database, and it might be poorly documented, so it might be hard to get the right setup. Bit rot. So sometimes external dependencies can take out all of your tests. It might be node module, something like that, gets updated without you realizing, and that's a whole day lost. Shared state, sometimes you might have scenarios where one test relies on another to be finished before it to actually work. Reliance on mocks, just because it works with mocks doesn't mean it'll work in the actual environment. And CI pipeline consistency, so because you're using different environments and they have different setups, you have no real guarantee that they're going to work. So sometimes you might have tests that only work CI, sometimes they only work locally. And in the past, when we were working with monolithic architectures, it was quite easy to do integration tests where you usually only have a couple of dependencies, maybe one database, maybe you talk to some other external system. But these days, every service always has something else it's going to communicate to. You're always using the best tool for the job. And then if we factor in cloud infrastructure as well, where not only do you have to worry about your services, you have to worry about things you communicate with in the cloud. So it might be buckets or Lambda functions, something like that. So if it's so difficult, why should we even do it? And here's an example of if you only do unit tests. So here's 2 unit tests that will pass, but use them together and it doesn't work at all. So for integration tests, the benefits of them are you can simulate a real world scenario and run them in isolation. You can find issues before the real environment, and you can still run them during development, so you'll catch issues fast. And disadvantages of them are you have to use real databases, and it's not always cross-platform where there's different support depending on the system you're using, and they're slower than unit tests. So in an ideal scenario, how should you structure your tests? And this is the test pyramid, where as you go down the pyramid, things get faster and more precise, and you should have a lot more of them. But just because you have quantity doesn't mean quality. It's actually the things towards the top that are doing more functional tests. And today we're focusing specifically on integration tests. So how can we make integration tests easier and more reliable? We can use Docker. So what is Docker? Docker allows you to spin up containers that allow you to package your software. So it should be packaged once and run anywhere. And it allows you to run your apps in isolation. And it runs on top of the OS kernel. So all you're concerned about is the actual app. So they're pretty lightweight and they're portable and should work on all platforms. And one of the terminologies we'll be using today is an image, which is the basis of a Docker container. And the difference between a container and a virtual machine. So container, like we said, is more focused on the actual app, whereas virtual machines you need to package along an operating system, so they're a bit more cumbersome, and yeah, less portable as well. So why do we use Docker containers? Speed, because we have no operating system to boot, portability, and no OS overhead. So Docker's pretty popular for kind of building and deploying your applications. Why can't we do the same for our test? So here's where something like TestContainers comes along. The definition on the Java fork of this is it's a library that supports JUnit tests, providing lightweight, throwaway instances of common databases, web browsers, and anything that can run in a Docker container. So features that it offers: containers as code, where it allows you to start and stop Docker containers on demand, automatically discovers the environment you're running this on, and will use the specific things. So it might be Docker for Windows, Docker for Mac, or Docker machine. And it will automatically start it up if it's not already running. And it allows you to do port randomization, so you can avoid things like port conflicts. And it'll do cleanup afterwards. So a common thing you'll find in CI pipelines is if you're running tests constantly on the same environment, you might run out of memory because there's containers that you just haven't shut down properly. And what can be used with? So today I'm going to cover the JVM one, which can be used for pretty much all JVM languages. I'm going to do Java examples, but it's got good support for Groovy Spock and Kotlin and Scala. There's other options to use this with Node, Go, and Python, different forks of this repo, and early development for other things like .NET and MicroProfile. So what kind of things can you spin up with this? So it has support for all the main database systems. You can also do automated UI tests, and if you want to spin up a lot of containers and you don't want to kind of outline each one, you can use Docker Compose, and you can do Dockerfiles as well, and generic container where you can just pass the image name and it'll search Docker Hub, which is a public hosted image repository, or your own private one, so it just uses the settings you have already for Docker. So some examples. Generic container. So this is using JUnit, and here we are just setting up a generic container, and we're passing in the image name, which is Redis, and the version number, and exposing a port. And this port isn't actually the one that's used on the host. It's a bit of a, what's the word? It's using a random port on your host, and this is how you'll reference it later. And then if we use class rule, it'll spin us up at the start of a test and close it down at the end. So like I was saying here, it automatically on your machine finds what local Docker environment you're doing. It'll do the checks to make sure you're running the right version, and it can be ran. Pulls out images, starts and stops the container for you, and waits to be ready before it's used, and does the port mapping and cleanup afterwards. And benefits of doing it this way: no need to install a dependency on your machine. All you really need is Docker, and if you're running this in a CI environment and you Dockerize everything else, then it's no extra overhead to run this. And then it's only running for the duration of the test. And no concern over version or configuration differences. You can always change it whenever you need. And exact same tests running between locally and CI, no environment changes. And we avoid port clashes and shared state unless we want to. And things we've gained: repeatability. We can set up one container, use it across multiple things. We can also add in breakpoints and debug real instances of things. We can run things in parallel, and you can run anywhere that Docker is able to run. So here's an example of a database container. At the top, we're setting up that we want a MySQL container and specifying the version that we want. And then once that's spun up, we're able to do get calls on it to actually find out how we can interact with this. So here we can get the JDBC URL, and that's what you might use in your test, or you might get the database name. And a more advanced example where you can do things like apply scripts at startup. So if you're using something like Flyway to manage your migrations, then exact same can be used for your tests. And you can add logging and other stuff like that. This is just a small amount of things it can do. So it seems a bit cumbersome to have to use this when you can just use embedded databases. In Java world, H2 is the most popular example, but it is fast and easy to set up, but it's still not the exact same as the real environment. So with MySQL, you don't really find it that much, but things like Postgres, where if you wanted to have your tests work, you have to leave out features of Postgres just to make it compatible. So you shouldn't make your production build less efficient just to get tests to run. And now for an example of UI automation. So we're going to be using Selenium WebDriver, and this will spin up a headless Docker container for either Google Chrome or Firefox, and it has features that you can set it to record the session and only record it if it fails as well, and you're able to debug as well doing this. So here's a demo. So there's code on the left. It's probably quite small, but all it's doing is it's going to Wikipedia and it's going to search for Rick Astley, try and find some memes on that page, and afterwards it produces this video. And real world scenarios for this would be, you could let's say you're doing tests and you find an issue, you could upload the video up to AWS, something like that, and link it in a Jira ticket so developers can instantly reproduce the problems. And at the top, we're setting up a browser WebDriver container, and we're just setting that we want to use Google Chrome and that we want to record all output and the actual directory to send it to. You could do more advanced things, like I said, sending to some sort of cloud provider. So Docker Compose, the benefits of using this. So rather than outlining each one, so the benefits of Docker Compose is you can kind of put everything into one config file and that will manage things for you. And some of the downsides with Docker Compose is if you want to make sure that there's no zombie containers, basically the tests are already ran, but containers are staying alive, so it's using up memory. You have to kind of come up with your own manual ways to do that. And in test containers, rather than outlining all your containers like this, you can put them in a Docker Compose file, and it's able to read that fine, and you can pass it in using Docker Compose container, just say the path of the file, and you're even able to make changes after it's been read in. So it's just finding it by the key. So database cache search. And then another example, you can read in Docker files. And if you don't have a Docker file, if you don't have something that has a custom image, you can actually just create one on the fly like this. So this is using a DOCKERFILE builder. And some more advanced options. So test containers is really just a wrapper for Docker Java API. So if there's anything test containers hasn't actually implemented yet that you want to use, you can pass in a command like this. So anything that Docker Java supports, you can just pass it manually this way. So what's the catch with using this? There has to be a catch. Slowness of container startup. Considering what it's doing, it's not that slow, but it can be a bit cumbersome. So there are some strategies you can apply where maybe you don't spin up a container for every test, and maybe structure your tests so that they're test suites and you start up a container at the beginning and end it. If you have multiple classes, you can set up a static initializer or singleton pattern, and they inherit in your test. And if you're completely sure that your environment will run test containers, you can cut out all the startup checks, which check that your Docker version is compatible, that you have Docker running, and it'll cut out half the time. So what's next? So hopefully today has convinced you that this is something worth exploring. It's still an early library. It's only been around 1 or 2 years, but it should just be another tool in your toolkit for testing. And if you want to find out more, there's documentation on the site, testcontainers.org. Is an open source library, so any issues you come across, you can just raise them with the team, and they have a very open Slack group that you can communicate with them.